Okay, we are live. If there is anybody in the chat section, please let me know if I am audible or not. Just give me a quick thumbs up in the chat section so that I'll know everything is fine with my stream. Just give me a quick thumbs up in the chat section, guys. Just give me a quick thumbs up. Shreya is asking why are classes getting skipped because of some availability issue. Like I have classes going on in at our center as well as I have online classes, so that's why we are not available. We are not able to regular take classes, but I am trying to take as I'll try to complete the whole syllabus for machine learning. Okay, thank you guys. Thank you so much. So in this session, we are going to discuss about naive-based classification. It's completely based on probability. So if you know the basic concepts of probability, you can easily understand this. So anybody knows what is Bayes theorem? Let me know, guys, if anybody knows what is Bayes theorem. So first of all, let's discuss conditional probability. So all of you know what is probability. If I want to find out probability of an event A, what is it? Total number of total number of outcomes or total number of possibilities and elements occurring in the set A, right? That is probability of event A. If I have to find out conditional probability, that means probability of A given B. That means probability of an event A when I know that event B has already occurred. That is by conditional probability. So what is the probability? Probability A intersection B upon probability of B, and this probability of B is not equals to 0 because the event B is already occurred. So we do have this event some probability. It is not equals to 0. So let's take one example to understand conditional probability, right? So if I want to know, let's suppose I have tossed two dice simultaneously, right? I have tossed two coins simultaneously. I have tossed two coins simultaneously, and I have already given that the first toss I get a head, right? So we have to find out the probability of getting head on second toss. So how do I find out this probability? Anybody know? Just let me know what would be the probability here. This is conditional probability. I have tossed two coins simultaneously, right? First toss, I already know that is head. Then I have to find out probability of uh, getting head on second toss. What would be the probability? So if I'll consider this getting if I'll take this A as getting head on second toss and B would be the uh, getting head on the first toss. So I know that because B is already occurred, so I have to find out probability A given B. So that would be probability A intersection B upon probability of B, right? What is A intersection B? That means first toss is head and second toss is head. If both tosses are head, what would be the sample space? Sample space would be head head, head tail, tail head, and tail tail, right? So we know that we want that first toss is head, second toss is head. So that means this one. So probability of A intersection B would be 1/4. Probability of B would be probability. That means first toss is head. I have to find out what would be the probability of B. So I know that first toss is head is these two. In these two cases, I have first toss is head. So that would be 1/2. So on solving, we'll get the probability 1/2. Because here ordered matter that on the first toss, I got head. Let's suppose they ask me that probability of getting on first toss on one coin. On one toss, I'll get uh, a head, and on another toss, I have to find out another toss. right? So here order does not matter, so it would become 1 by 3. So probability would become 3 by 4. Sorry, it would become 3 by 4. Let me write down 3 by 4, and probability of B would be, what would be the probability of B? 1 by 4. A intersection B is 1 by 4, and it would be 3 by 4, right? So it would become 1 by 3 is the probability. Okay, so that is my conditional probability. I hope it is clear that what is conditional probability. If I have probability A given B, I just have to find out probability A intersection B upon probability of B, right? According to this, sometimes we are able to find out, let's suppose it is given that what is probability of A given B, and because with the help of this, if I have to find out probability B given A, how do I find out? With the help of probability A given B, I have to find out probability B given A. So we are going to use Bayes theorem for that, right? So let's see how we are going to find out. So Bayes theorem says that if I have to find out probability B given A, it is equals to probability A given B into probability of B upon probability of A, right? That is my definition for Bayes theorem. So you can see that with the help of A given B, I am finding out B given A probability. Okay, so let's take one question and solve it. So we have this question. It says that consider a set of patients coming for treatment in a certain clinic. A denote the event that patient has a liver disease. B be the event that patient is alcoholic. It is known that 10% of the patient entering the clinic have liver disease and 5% of the patients are alcoholic. Among those patients diagnosed with liver disease, 7% are alcoholic. Given that a patient is alcoholic, what is the probability that he will have a liver disease? Solve it, guys, and let me know what would be the answer here. Just try to solve it. Using Bayes theorem, you have to solve it. Because if you are not able to find out the probability, then it would be difficult to understand naive Bayes. If there is any confusion, just let me know in probabilities definition. But try to solve this question. Try to solve this question, guys. So here you can see that if I'll take the A be the event that patient has a liver disease, A be the event that patient has a liver disease, right? And B be the event that person is alcoholic, right? It is known from the experience that 10% of patients entering the clinic have liver disease. So that means probability of A is equals to 10 upon 100, and 5% of the patients are alcoholic. That means probability of B is equals to 5 upon 100, right? Among those patients diagnosed with liver disease, 7% are alcoholic. That means we have given that the persons are diagnosed with liver disease. Out of persons who are diagnosed with liver disease, 7% are alcoholic. So that means probability B given A is given to us 7 upon 100. Is it clear that how I have written these things? Now they are asking that given that a patient is alcoholic, that means we have to find out patient is alcoholic. What is the probability that he will have a liver disease? I have to find out probability A given B here. Right? So what would be the formula according to Bayes theorem? What would be the formula? Simple thing. Probability A given B is equals to probability B given A into probability of A upon probability of B. Right? So what would be probability B given A? So let's write down. Probability B given A is given to us 7 by 100 and probability of A is equals to 10 by 100 and probability of B is equals to 5 by 100. So if I'll cancel this 100 and 100 and cancel this 0 with this 0, I'll get 7 by 50. Right? So 7 by 50 is the probability of A given B. Or I can write down 14 by 100 or 0.14% is the probability. So I'll say that 14 by 100, and I can write down 14% are the patients who are if 14%, if a patient is alcoholic, 14% chances are there that he will have a liver disease. Right? Is it clear with everybody? Just let me know, guys, if there is any confusion in finding out, in understanding this Bayes theorem. Just let me know in the chat section. Is it clear? Just give me a quick thumbs up in the chat section if this is clear. Otherwise, I'll tell you more about it if it is not clear. Okay, so then we have a generalization of a Bayes theorem. What is this generalization of this Bayes theorem? So what it says that, let's suppose we have an event A and it is a union of all those events B1, B2, B3 and Bn, right? It is union of all these events B1, B2, B3, Bn. And if I have, and these B, A is what? A is equals to B1 union B2 union Bn. And also these intersection of these B1 Bi intersection Bj is equals to 5, where I and j varying from 1 to n, right? So that means A is a union of B1, B2, Bn, and Bis are mutually exclusive, right? These are mutually exclusive events. Then I can find out probability of A. So there are sometimes possibilities that I have to find out probability of A with respect to this Bi. So I can write down probability A given B1 into probability of B1 plus probability of A given B2 into probability of B2 plus probability of A given Bn is into probability of Bn. Right? So this is what? This is my law of total probability. This statement is called as law of total probability. So what I am doing here, I am taking total of all the probabilities to find out probability of A. Law of total probability. Is this law of total probability clear? Then we'll move to generalization. Law of total probability says that if I have to find out probability of A, and A can be divided into n events B1, B2, Bn, such that their union forms an A, and these Bis are mutually exclusive, right? Then using law of total probability, I can find out probability of A with the help of probability A given Bis and Bis. Is that clear? That what is law of total probability? And if you remember, according to Bayes theorem, I have this, that probability of B given A is equals to probability A given B into probability of B upon probability of A, right? We have this. But sometimes what happened, we have the sample space divided into disjoint events B1, B2, Bn. Instead of exactly getting B, we have some Bk here. So if I have to find out probability of Bk given A, so what would I do? Probability A given Bk into probability of Bk upon probability of A. But there might be a possibility that probability of A is not given to you, but it is given that A is a union of all these events B1, B2, Bn. Then you can find out probability of A using this law of total probability, and that is the generalization I have written here. That summation I varying from 1 to n probability A given Bi into probability of Bi. Is this thing clear? That what is a general? How do I get this generalization? So let's start from the start. What I have done, I told you we have a event A. I have to find out the probability of event A, and I do not have anything regarding the probability. I have given that A can be divided into disjoint events, that is B1, B2, Bn, right? But I do not have probability of A. I have probability of A given B1, probability of A given B2, and I have probability B1, B2, Bn. So with the help of that, what I can do, I can find out probability of A. What is the formula? Probability A given B1 into probability of B1 plus probability of A given B2 into probability of B2, like this. We have to take the sum over the all events. And I call this as law of total probability. Is this thing clear? Once we are clear with this law of total probability, let's get back to Bayes theorem. Bayes theorem says that probability B given A is equals to probability A given B into probability of B upon probability of A. This is what? This is my Bayes theorem. But here, because we have said that sample space be divided into disjoint events, B1, B2, Bn. Instead of B1, B2, Bn, if I have any, instead of capital B, any one event, I have here Bk. So what would happen? All gets changed Bk. But again, there might be a possibility that if A is given, formula remains same. If A is not given, probability of A is not given, then I'll use this law of total probability. Just let me know, guys, is this thing clear? Then we'll move to the question. Otherwise, I'll explain this again. Just let me know that this Bayes theorem clear or not. What I have done here. So here you have to remember only two things: Bayes theorem and law of total probability. This comes by both the things. Just let me know, guys. Then I'll move forward if you will tell me that everything is clear to you. Let me know, guys. Is this thing clear? Okay, so let's move to the question. So this is a question given to us. Three factories ABC of an electric bulb manufacturing companies produces respectively 35%, 35% and 30% of the total output. That means A factory produces 35% of the production, B produces 35% of the total production and C produces 30% of the total production. Approximately 1.5%, 1% and 2% of the bulbs produced by these factories are known to be defective. That means out of first factory, A factory, 1.5% bulbs are defective, out of B, 1% are defective, and out of C, 2% are defective. And they are saying that if a randomly selected bulb manufactured by the company was found to be defective, so that means we already gotten that the bulb is defective. What is the probability that bulb was manufactured by factory A? That means if I'll focus on the question, if a randomly selected bulb manufactured company was found to be defective, probability that bulb was manufactured by factory A. So I have to find out probability A given, and I already know that it is defective. I have to find out the probability. When I already know the bulb is defective, I have to find out the probability that the bulb was from produced by the factory A. Is this thing clear, guys? That I have to find out probability A given D. So if I'll go back to my uh, Bayes theorem, because I do not have in the above information. Let's see what are the above information I have. So if I have given probability of A, that is 35%, 35 by 100. Probability of B, that is again 35 by 100, and probability of C, that is 30 by 100. And you can see that approximately 1.5%, 1% and 2% of the bulbs produced by these factories are known to be defective. So that means out of, when I know that the company's A is producing, 1.5% are defective. So can I say that probability of defective when I know that it is produced by company A is what? 1.5%. Right? Probability of defective when I know that it is produced by company B, that is 1 by 100. Probability of defective from the company C, 2 by 100. Yes. Now what I have to find out? Probability A given B, A given D. So I know the formula: probability D given A into probability of A upon probability of D. This is a formula? This is a formula, guys. Now, probability D given A, I already have. Probability of A, I already have. But I do not have probability of D, right? So to find out probability of D, what I have to do? I have to use law of total probability. So how do I find out probability of D? So you can see that probability of defective. Now this defective can be divided into disjoint events. That defective comes from company A, defective comes from company B, and defective comes from company C. So because three factories are producing bulbs, so we have to find out probability of getting defective bulbs out of all these companies. So what would I do? I'll use law of total probability. So what it would become? Probability D given A into probability of A plus probability D given B into probability of B plus probability D given C into probability of C. Right? So what is probability of D given A? 1.5 by 100 into probability of A, that is 35 by 100, plus probability of D given B, 1 by 100 into probability of 100, 35 by 100, plus probability D given C, 2 by 100 into probability of C, 30 by 100. Now we can solve it. What would I get? 15 into 35 into 1.5. 35. Just check the calculation, guys. So it would become 52.5 by 100, 35 by 100, 60 by 100. Right? Okay. So let's add these 60 and I'll add it with 35. 147.5 by 100. Right? Just tell me, guys, if this is clear. Now I can write down, I can fill all the probabilities to get the answer. 1.5 by 100 into what is probability of A? 35 by 100. And I have 147.5 upon 100 into 100. Guys, this would be because 100 into 100. So we have one more 100 here. I have left this by mistake. 100 into 100. Then it would be a probability, right? So now let's solve it. Hundreds are cancelled. Let's cancel this. 5 threes are 15. 5 twos are 10. 45, 46, 47, 35. 5 sevens are 35. 9 threes are 27. 99. Just check the calculation, guys. Is it correct or not? So you would get answer from that. Right? Just check the calculation. It's all calculation. It would be 5. I have made a mistake in calculation. 295 and 390 are 27. 3 doesn't get cancelled from here. So we'll have 3 here. 5 sevens are 35. So we'll get something 21 by 59. Just check the calculation, guys. So you would get the probability. So I hope you get the concept that how would you find out, how would you work on Bayes theorem? If you have a distribution into disjoint events, then how would you solve? If you have given directly, then how would you solve? Because students think that Bayes theorem is difficult. It's not at all difficult. If you would understand the concept behind it, then you can easily solve it. Guys, just let me know that if there is any problem in Bayes theorem, we'll discuss that. Otherwise, we'll move to our main algorithm, that is naive Bayes algorithm. Guys, we can expect, because this is completely numerical algorithm, so we can expect questions from this topic in GATE exam. So just let me know if there is any confusion. Otherwise, all the students, let me know if this is clear or not. Okay, what about other students? What about other student? Is this Bayes theorem clear or not? Okay, so let's move forward. if this thing is clear. So let's discuss what we have to do in naive Bayes. Basically, naive Bayes is used for classification, right? So you can see on the screen that we have a data given to us. So we have here swimming, fly, crawl, and classes. So according to these features, these are features F1, F2, and F3. We have these three features that if a person swim fast, if a species swim fast, it does not fly and it does not crawl, then it is a fish, right? So we have classified using the features a particular species. If a species is fast, it does not fly but it crawls, then the species is an animal, right? And you can see that if a species does not swim and it is short fly and it does not crawl, then the species is a bird, right? So you can see that we have this data set. So that, let's suppose if somebody asks me that if we have one species that does not swim but it flies rarely and it crawls. So how I want to classify this? I want to find out class of the species. So you can see that in my previous data set, we do not have any data in which person does not, the species does not swim and it does not rarely fly and but it crawls. So I, according to these features, I have to specify that what would be the class of a species. So you can see that in this data set, if I'll find out the probability, let's say classes. So this is C1. C1 is a fish, C2 is an animal, and C3 is a bird. We have three classes here. You can see that either I can specify as fish or classify as fish, as animal, or as a bird. So we have three classes. Let's say that these are C1, C2, C3, right? And features are F1, F2, F3. Let's, instead of taking F1, F2, F3, okay, yeah, let's take the features F1, F2, F3. So I want to find out, so in naive Bayes, what would we do? We'll find out probability of C1 given that the species is fly, sorry, does not fly, or I can say that F1 is equals to no and F2 is equals to rarely and F3 is equals to yes. So if I'll find out this probability, again similarly, if I'll find out the probability of C2 such that F1 is equals to no, F2 is equals to rarely, and F3 is equals to yes. And similarly, if I'll find out probability of C3 is equals to F1 is equals to no, F2 is equals to rarely, and F3 is equals to yes. If I'll find out these probabilities, these three probabilities from this data set, so the which has the maximum probability, that would be a class. Any class out of C1, C2, C3 has maximum probability. So we can say that if these are the features, then the probability of having this particular class is maximum. So we'll specify that these features, that class. So let's suppose C2 has the maximum probability. Let's consider by ourselves. Let's assume that you are getting 0.14, 0.78 and 0.01. We got these kind of probabilities. Basically, we have to make the sum 0.9 to 0.08. This is the probability, right? These are the probabilities. So you can see that C2 has the maximum probability. So I can classify this no, rarely, and yes as animal, right? So that's how I can specify or I can classify using my data set. But the question is that how do I find out these probabilities? Just let me know the concept of naive Bayes clear or not. Just let me know that naive Bayes is clear or not. What we are trying to do here, we have one data set, and let's suppose they have given some of the features specific value. I want to know that with which class I'll specify that particular value. So what would I do? I'll take that class, and given, I'll take the features which are given to me, and corresponding to that, I'll find out the probability. So that means I'll find out the probability of each of the class corresponding to that, given that the features I have given, F1, F2, F3. If I'll find out the probability for this, what would I get? The class which has maximum probability, we will specify that particular class. So let me know, is there any question in this? Then we'll see that how to find out these probabilities, because that is a question. There will we use we'll use their naive Bayes theorem. Let me know, guys, is there any question here up to this point? Let me know if there is any question. Otherwise, we'll see that how to find out these probabilities. Okay, so let's see. So let's see how will we find out. So test instance, here we are taking slow, rarely, and no, right? So it's up to us. So test instance matlab, that means I am taking swimming as slow, and rarely as fly, and no as crawl. Okay, so now let's move forward. So using Bayes theorem, so what I have to find out, so let's take this feature as capital X. Capital X is basically combination of x1, x2, x3. It is a vector. So that means x1 is slow, x2 is rarely, x3 is no, right? So I have taken capital X is equals to x1, x2, x3. That is, let me write down here. Capital X is x1, x2, x3. That is slow, rarely, and no. Right? So basically, I have to find out probability C1 give Ci given X. So which for particular I, let's suppose C1 is maximum, then I'll classify as C1. If C probability of C2 given X is maximum, so I'll classify my given test instance as C2. Otherwise, I'll classify it as C3. Is it clear? Let's see further. Let's see. So we know that probability of Ck given X. Basically, I have to find out probability Ci given X. That means probability Ck given X. Using Bayes theorem, I know that I can write down probability X given Ck into probability of Ck upon probability of X. Right? So that means I'll find out probability C1 given X, probability C2 given X, and probability C3 given X. In this question, I'll find out these three things. Okay, so let's see further. This step is clear to everybody, right? If there is any question, please ask. So let's consider this probability X given Ck. So if I'll consider this, because I have probability of Ck, I can find out easily. How do I find out probability X given Ck? So X is what? Probability of X1, X2, Xn. There may be a possibility that we have n features corresponding to Ck. So because X1, X2, Xn features, these features are independent of each other. That means they would not depend on any of these. So I can write down here this probability of X1 Ck into probability of X2 Ck into up to probability of Xn given Ck. So you can see that I have written here probability of X1 given Ck, X2 given Ck. I have break down these. I can easily break down. This step is clear, and this so we get the probability formula, probability Ck given X. So I can find out probability X1 given Xk, X2 given Ck, Xn given Ck, and probability of Ck. But this probability of X is common in each of the formula, right? If I'll find out probability C1 given X, then there would be a denominator probability of X, probability C2 given X, then there would be probability of X, and probability C3 given X, there would be a probability of X. So it would remain same in each of these. But you can see that in numerator gets changed. So that means denominator does not make any difference, right? So what I can do, I can write down this formula instead of writing probability of x in denominator. I can write down this as the denominator probability x is independent of class labels because it does not include class labels, so it is not changing for any of the class. So if I'll remove it, it does not make any difference in probability. So I can write down in measuring either maximum or minimum of the probability, right? So probability ck given x, I can write down probability x1 given ck, probability x2 given ck, up to probability xn given ck into probability of ck, right? So is this thing clear? Right, so I am going to use this formula to find out all the probabilities I told you previously. Right, so that means I'll find out here probability C1 given capital X. That means I have to find out probability C1 given X1, probability X1 given C1 in this case, and X1 is slow. Probability of being slow when we have given that it is from class C1, probability of x2 given C2, and probability of x2 given C1, probability of x3 given C1 into probability of C1. So we can find out this probability. Similarly, we can find out C2 given x, C3 given x, and the probability which takes the maximum value, we'll classify that test instance as that particular class. Is this thing clear? Let's solve one question, then it would get clear to us that how we are going to find out these, how we are going to attempt these formulas in a question. Okay, guys, just give me a quick thumbs up in the chat section if there is no confusion. If there is any confusion in the formula, then we'll discuss it once more, because I do not want that you have any confusion while we'll solve question. Or do we first solve the question, then you would get to know that everything is clear or not? Tell me, guys, if I have to repeat this again, because this thing is really important. There may be a possibility that they can ask you regarding this mathematics. Okay, so one student is only answering. What about other students? These you guys are not getting it, then ask. Otherwise, just let me know that you guys are getting what I'm teaching here. Let me know, guys, so I can move forward to the next question. So now our test instances, slow, rarely, no, I have to specify, I have to classify that in which class. Either this class is animal, bird, or fish. I have to classify. What about other students, guys? Just let me know in the chat section so that I can move forward. Okay, so let's solve the question. So this is a test instance, slow, rarely, and no, right? Okay, so I have to find out, let me solve it. So that means I have to find out the probability of C1 given X. That means it would become probability of X1 given C1 into probability of X2 given C1 into probability of X3 given C1 into probability of C1, right? So how do I find out probability X1 given C1? So first of all, in this, we have to find out probability of C1. So C1 is, let's say C1 is fish, C1 is fish, and C2 is animal, and C3 is bird, right? Let's talk about fish. So you can see that I have 12 instances, 12 examples, not instances. I have 12 examples. Out of those, I have 1, 2, 3. 3 fishes. So that means probability of C1 would be 3 by 12. right? So now let me box it. This is fish and these two are fishes. Right? Now let's find out probability x1 given c1. X1 is what? Slow. Probability of slow when I know that class is fish. So class is fish in these three, right? Probability of slow. So this is fast. So we have two slow instances, two slow data, right? So out of three, I have two slow, right? Probability of x2 given c1. C1 is what? Fish. So that means these three I have to consider. So out of this, x2 is rarely. So we do not have anything here rarely. Fly is not rarely here, not rarely here, not rarely here. So that means this is 0 by 3, right? Probability of x3 given c1. So c1 is fish and crawl is no. So we have 1 no, 2 no. So I can write down this as 2 by 3. Just let me know if this is clear, that how do I get this probability. So on multiplying, I'll get probability c1 given x is 0. Right? Probability c1 given x is 0. So that means uh, this instance cannot be a fish because we are getting probability 0. There is no probability we get. Similarly, I can find out probability c2 given x. So c2 given x would be probability x1 given c2, probability x2 given c2, probability x3 given c2 into probability of c2. So c2 is what? C2 is an animal. So let me remove this because I do not need now fish. Now let's consider only fish. So when we are finding out C probability of C1, just consider only where you are getting C1 class. When I am getting C2 class, I'll consider only that. So now C2. So C2 is animal. So in these three cases, I am getting animal, and in these two cases, I am getting animal. So out of 12 examples, 12 data points, I am getting 5 as an animal. So that means probability of C2 is 5 by 12. 5 by 12. Right? So we have 5 examples for animal. Now probability of x1 given c2, probability of slow when class is animal. So class is animal in 5 cases. Out of this we have 1 slow and 2 slow, because we have to take only those swimming slow when we have animal class. So we have animal class we have 2 slows. Out of 5 we have 2 slows. So that would become 2 by 5. X2 given C2. That means we have to see that fly is equals to rarely when the class is C2. Fly is equals to rarely. So we have this in one case only. So I'll write down here 1 by 5. And X3 given C2. X3 is what? No. So let's see in animal when we have no. We have no here, we have no here, have no here. So out of 5, we have 3 no's in crawling. So 3 by 5. So let's find out this probability. 3, 5 get cancelled, 3 4s are 12, 2 2s are 4, 2 5s are 10, and 5 5 25 to the 50. So 0.02. Right? This is a probability C2 given x. That is 0.02. Similarly, I can find out probability C3 given x. So guys, solve me and let me know what is probability of C3 given x. Just let me know guys what is probability of C3 given x. Just let me know guys in the chat section. Let me know guys what is probability of C3 given x. Just try to find out by yourself. So that means what would I do here? Probability x1 given c3 into probability of x2 given c3 into probability of x3 given c3 and into probability of c3, right? So let's see what are the c3 classes. C3 is what? C3 is fish. So let's see where we have fish in my data set. Sorry, C3 is bird, C1 is fish, right? Okay, one student is saying that it is 0. So we have bird here, we have bird here. So that means in 4 out of 4 data point, out of 12 data points, we have 4 birds. So that means probability of C3 would become 4 by 12. Now find out probability x1 given C3. X1 is what? Slow. So let's see where we have slow. We do not have slow when we have class bird. So that means this is what? 0 by 4. X2 given C3. X2 is what? Rarely. Again, we do not have anything fly as rarely in my data point when I have class bird. So that means 0 by 4. Probability of x3 given C3. That means no. So that means scroll 1, 2, 3, 4. That means 1 is a probability here, x3 given c3, because each have no when we have a bird. But again, we got the probability 0, right? But here we have to see where we have the get the maximum value. So we get the maximum value as probability C2 given x. So I can classify this as a C2 class. C2 is what? Animal. So this is an animal, right? So you can see that everything depends on probability. Once you know all the base theorem and basics behind it, then you can easily solve. So there may be a possibility that they can ask you a question regarding the numerical part, or they can ask you the theoretical part as well. That's why I told you all the theory behind this formula. So you should know what is the basics of this formula, where we get this, right? Because for a competitive exam, you should know all the basics required. Okay, so is that thing clear? Just let me know, guys, if there is any confusion in this. Is this thing clear, guys? Just let me know this question is clear to everybody or not. Okay, so I think everything is clear. Okay, so let's solve one more question. So there may be a possibility that you can solve this problem using this table. There may be there can be a you can solve this by using a table, but I do not suggest to work using a table. So that's why I use the formula which I told you. So again, the question is, so this is a question. They are saying that use naive-Bayes algorithm to determine whether a red domestic SUV car is stolen car or not using the following data. Or not using the following data. Okay, SUV car is a stolen car or not. Whether a red domestic SUV car is a stolen car or not. And we have given the data set here, in which we have given color, type, origin, and we have to classify this as the classes, the car is stolen or not. That is yes or no. We have two classes here, right? So let's solve it. So where we here we have given red domestic SUV car. So that means X1 feature, let me write down, X1 feature is red and X2 feature is domestic and X3 feature is SUV. Sorry, X2 feature is SUV. X2 feature is SUV and X3 feature is domestic. So I have to specify class for this, right? So that means what I have to find out here, I have to find out probability C1 given X. Let's take C1 is equals to yes and C2 is equals to no. And X is what? X is why X1, X2, X3. So let me know what would be the probability C1 given X and probability C2 given X. Just solve it and let me know what would be the answer. We have given this data set here. Let me see if there are 10 points. Yeah, this is a data set. Just find out probability C1 given X and C2 given X and let me know in the chat section what are these probabilities. So for probability C1 given X, what would I do? I'll write down here probability X1 given C1 into probability X2 given C1 into probability X3 given C1 into probability of C1. Right? Solve it. Let me know, guys, what would be the answer. What would be the probabilities first? Find out probability C1 given X and let me know in the chat section. Find out probability C1 given X. So if I'll see C1, I have taken as yes. So we have in my data set, this is yes. This is yes. This one is yes. And then we have this one, which is yes. And then we have this one, which is yes. And we have the last one is yes. Okay, so you can see that I have 5 points, 1, 2, 3, and 4 and 5. So we have 5 out of 10 examples that where the car is stolen. So probability of C1 would be 5 by 10. Now I have to find out X1 given C1. X1 is red. So when the class is yes, see where we have red. We have red here, we have red here. And then we have yellow, yellow and red. So that means we get the probability 3 by 5. Right? Probability X2 given C1. That means when class is C1, we have to check that the car is SUV. In a number of cases where the car is SUV. Here we have sports, sports, sports. Here we have SUV and here we have sports. So that means probability would become 1 by 5. Right? Now I have to check that probability X3 given C1. When the class is C1, we have to find out what would be the probability of X3. That is domestic. So we have domestic here, we have domestic here. This is imported, this is imported, this is imported. So that means 2 by 5. So let's find out probability 5 2s, that is 10. So 3 by 125. Okay, so one student has given the right answer 3 upon 125. That is correct. Find out now probability C2 given X. Let me erase this, because now I have to consider class C2. That means no. So probability C2 given X, that means class is C2. That means no. So we have here no, and we have no here, and we have no here. We have no here. Okay. We have no here. Okay. So we have 5 cases in which we have no. So again, it would become probability X1 given C2, probability X2 given C2, probability X3 given C2 into probability of C2. Right? Probability of C2 is 5 by 10. Probability X1 given C2. So that means class is C2. When we have classes no, we have to find out probability that we have the color is red. So we have red here, we have red here. So out of 5 cases, we have 2 red. So this would become 2 by 5. X2 given C2. That means we have to find out when class is no, X2. That means the car is SUV. So we have sports here, sports here. This is SUV, this is SUV, this is SUV. So that means 3 by 5. Right? Probability X3 given C2. x3 given c2. That means c2 is no. Class, when class is no, we have to find out probability that the car is domestic. So we have domestic here, we have domestic here, this is imported, this is imported. So it would become 3 by 5, right? So if I'll solve this, 2 and 5 get cancelled with this 10, we'll get 9 by 125. So you can see that which probability is larger. Probability C2 given X, this is more as compared to C1 given X. So what would I say? That this instance, X1, that the car is red SUV and the domestic car. That means red domestic car, which is SUV, is not stolen, right? Because we would specify it as class C2. So I hope naive-based theorem is naive-based algorithm is clear to you. Just let me know, guys, in the chat section if there is any confusion in this. So let me know, guys, in the chat section if there is any confusion regarding this. Is there any question, guys? Does anybody have confusion in naive-based algorithm or in this question? Just let me know in the chat section. I can repeat it again if anybody of you doesn't get it. Just let me know. Okay, everything is clear. What about other students? So in the next session, we are going to discuss K nearest neighbors in detail. I think if, okay, KNN we already have discussed. So the next algorithm we have in your syllabus, we'll discuss that and we'll discuss the questions based on that as well. Let me see what you have in the next. Okay, we'll discuss support vector machine in the next lecture, in which students have maximum time confusion. We are going to discuss that. That is SVM. So if there is no question, let's end this session. Guys, there might be a possibility that I'm not able to take class regularly, but because I am preparing for these lectures and also I am providing you questions so that you can solve in the lecture, right? So we'll discuss end-to-end algorithms throughout this year. So you can ask me after the session as well in the comment section if there is any confusion. We can discuss those questions in the next session. Okay. So yeah, that's all from my side, guys. Just share these lectures with your friends and all so that they can also take benefits from these free sessions. Okay, so yeah, that's all from my side, guys. Thank you for joining.